the horizontal line. And that was from the letter A to the letter B. That horizontal line is the line that you want to pay attention to. Classifying the angle, so for example, this angle right here would be labeled an angle of depression. Over here, angle B would not be labeled angle of depression or elevation. Angle C, you kind of have to look at it like this, and that would be, it's technically neither, but it could fall under angle of elevation if you wanted to look at it, but neither would be a better idea. And the key thing here is you guys always have to look for that horizontal line or the horizon. Okay? Depending where you're at will determine if you're going an angle of elevation if you gotta look up. If you're a plane flying in a straight line and you gotta look down, that would be an angle of depression. And there was a plane problem there. Okay. So number 2, multiple choice, 15-foot ladder rests against a tree on level ground and forms a 75-degree angle of elevation. You should have drawn a tree. And it says the 15-foot ladder rests, so there's a 15-foot ladder. And it rests against a tree and on level ground and forms a 75-degree angle. The angle is right here. So that, what is the correct location of the angle? It is between the ladder and the ground. Okay. All right, number 2, were there any questions on that one? All right, number 3, it says Tammy Jo, whose eyes are 5 feet off the ground. So you got to keep in mind that the person's eyes are 5 feet off the ground. So when you're making your drawing, you got to keep under consideration that whatever the person is looking, when they look through the clinometer, remember today we're going to measure the height of the tree and the height of the building. Okay? When you are going to start the activity, make sure that the clinometer, the little string, which is this one right here, make sure you're starting at 90, so you need to hold it up nice and straight, okay? Or 90 would be, okay? And you're going to look up, so you understand you're doing an angle of elevation. It says Tammy's, whose eyes are 5 feet off the ground, is standing 50 feet away from the base of a building. Remember, you guys are also going to get the height of this building outside. Okay? So you're 50 feet away. The angle of elevation is 73 degrees. And it says, to the nearest foot, how tall is the building? So you got to keep in mind a couple things. When you're measuring the building, this piece right here measures 5 feet. This piece over here, we don't know what it measures yet. And 5 feet because depending on the height of the person, that could change. Okay? Now, out of the 3 that you have to pick from, sohcahtoa, okay, out of those 3, which one can I use? Sine, cosine, or tangent?
Tangent.
Tangent. Tangent is the one you're going to use. You can't use sine because sine is opposite over hypotenuse. This is the opposite, which is x. I don't know what it measures. You don't have to use x. This is the adjacent. And over here is the hypotenuse. Hypotenuse is always opposite the 90-degree angle. Okay? So you're going to end up using tangent, which has opposite and adjacent in it, and you know 2 out of those. You have the angle measurement. So you would write tangent of 73 is equal to x over 50. Now, did everybody get a calculator? Calculators are right over there. Grab it. The drawing for these, if you guys don't do some type of a drawing to figure it out, that's where you might get stuck with it. Remember that the only reason you can use sine, cosine, and tangent is if you can make a right triangle. Okay? If you can't make a right triangle from your drawing, you're not going to be able to use sine, cosine, or tangent. It has to be a right angle in the triangle. Okay? Number 5, a pilot is traveling at a height of 30,000 feet above the level. So do you guys see the space that you're given? Do you realize it doesn't make sense to draw your plane down here on the bottom? You should draw a plane up here somewhere. And it doesn't have to be a perfect plane. Okay, there's a somewhat of a plane. Okay? Now, when it's flying, if the plane is flying at 30,000 feet, that means it's flying constantly at 30,000 feet. So the flight pattern that it takes and the ground that is traveling, assuming that the ground is flat, that they're parallel lines. All right. So now it says, she looks down at an angle of depression. So the pilot, she looks down at an angle of depression. Look at what happens. She's flying, she looks down from this line, not from this one. Okay? So she looks down and she spots a runway at an angle of 6 degrees for an angle of depression. But then it says, as measured along the ground, how many miles away is she from the runway? So you guys have to do a few more lines. Now, one of the lines that you guys have to draw is from the plane, directly below the plane, a straight line perpendicular to the ground. Because the question is asking, as measured along the ground, how many miles away is she from the runway? It's asking you for the adjacent to this angle. Now, does everybody see that these two angles are alternate interior angles of parallel lines? And the reason why I know they're parallel is because the plane is constantly at 30,000 feet above the ground. And the ground is assuming that the ground is flat. That means this angle measures 6 degrees. So this is my opposite side to the angle I know. This side is my adjacent. Over here is my hypotenuse. Out of those 3 sides, where does the 30,000 feet go? Yes, on the opposite. That means the plane is, you guys agree? The plane is 30,000 feet above the ground. Now the line that's the red line from the plane to the runway. So here's the runway. There's the runway. She's trying to make it to the runway. She wants to know how much farther from the ground to the runway it is. So you need to find out one of them that has opposite and adjacent in it. Which one has opposite and adjacent in it? And the reason why I had you guys write sohcahtoa, so you don't forget those orders of those letters. Sine has opposite and hypotenuse, so we're not going to use sine. Cosine has adjacent and hypotenuse. I need tangent because it has opposite and adjacent. You know what the angle is, so that's tangent of the angle, which is 6 degrees. Opposite is 30,000. And adjacent is x. We don't know what the adjacent side is. Now, to solve this for x, everybody eyes up here. If I times everything by 30,000, you notice that the x is on the denominator of that fraction right there? If I do that, I'm going to get a really big number from this. And I'm just going to have a bigger number over x now if I times it by 30,000. And you still haven't gotten x by itself. 30,000 only cancels out with the 30,000 on the bottom. See that? You're not canceling. So what you gotta watch out for is you're not gonna multiply by 30,000. You need to multiply by x to both sides. This one's on the bottom. That x with that x, those become 1. Same thing divided by the same thing is 1. That gives you x times tangent of 6 degrees is equal to 30,000. Now, divide by tangent of 6 degrees to both sides. And you see that you get x by itself now? So x is equal to 30,000 divided by the tangent of 6 degrees. So type that into your calculator. 30,000 divided by the tangent of 6 degrees. Close that. And you see the number I'm getting? Is that the number you're getting? Yep. Now, x is equal to 285,430, and these are all in feet. Give me answer the question. Think so? Jonathan, what do you think? Did you answer the question? No. Read the last sentence of the question, Jonathan.
Round to the nearest 10th of a mile.
It said round your answer to the nearest 10th of a mile. The answer is in feet right now. It's not in miles. Did everybody read the examples that I told you guys to read? Because in the examples, it tells you how many feet are in a mile. Does anybody know how many feet are in a mile? It's in those examples you're supposed to read. Find it. Now the examples I'm talking about are the ones that are the problems that were the ones with all the examples. You can have to read through that real quick now. Now that's telling me that you guys didn't read through them carefully then, so you guys are going to have to make sure you read through them carefully, okay?
5,280 feet.
Yes, 5,280 feet are in 1 mile. 5,280 feet is equal to 1 mile. Yes? Everybody find it? No? Okay, it's in there. You found it, right, Ian?
Yeah, that's awesome.
All right, so you guys see we have our answer in 285,430 feet right now. I need the answer rounded off to the nearest tenth of a mile. So what should I do with the numbers that I have? What do you think? What do you think? Not multiply. Divide. Divide all the feet that you have by 5,280 feet. Because for every 5,280 feet that you have, that's 1 mile, right? So divide that number, and you can just hit division by 5,280 feet. And you guys get this decimal 54.058, whatever. So what would that answer be to the nearest tenth of a mile then? Not 50. Not 55. 55 would not be correct. What would be the answer to the nearest tenth of a mile? Tenths place, first number behind the decimal. So you have to look behind that number. Is there a 5 or bigger?
54.1.
54.1 would be correct answer for the nearest tenth of a mile. Did everybody see that? And does everybody understand that in the reading that you were supposed to do, that it was in your reading? Yeah? Okay. Are there any questions on this one? Now, be very careful. If the thing that you're trying to solve for is on the denominator right there, it was on the bottom of the fraction, you have to multiply by it first and then divide by the value from here. Okay? Any questions on number 4? Everybody see the drawing? Okay, anything not making sense? Anything okay?
The only thing I messed up on was the multiplication.
Multiplied by 30. Now, if you multiply by 30, do you realize you're going to get 30,000 times another 30,000, and you're going to make it even bigger, 900,000, or maybe what is it? No, it's not. It's going to be more than 900,000. It's going to be 8 zeros and then 9 in front of that. In front of those 8 zeros. So we're talking about 6 digits is in the hundreds, is in the millions. 9 digits is in the billions. So it's at 900 million feet. But then you guys, do you realize that the denominator still has x in it? You didn't get the value of x to the top of the fraction. So that's why I had to multiply by x to both sides. Let me go ahead and erase this one. All right, number 8. A dog is 8 meters from the base of a tree. Let me draw a dog. All right, there's my dog. It's a dog, okay? All right, let me have everybody pause where they're at, because you guys should have already gotten this problem done. I don't have the time right now for you guys to be doing work. You have plenty of time to do that on your own, okay? I need everybody's heads up here. So the dog is 8 meters from the base of a tree. that 8 meters goes right there, okay? Then it says the dog spots a squirrel in the tree. So here's a squirrel. Spots a squirrel at an angle of elevation. So do you guys understand that the dog is looking up into the tree? And it spots it at an angle of elevation of 40 degrees. Okay? It says, what is the direct line distance between the dog and the squirrel? If you look at where the dog is and where the squirrel is, and now you label all your sides, the opposite side, the adjacent side, and this is the hypotenuse, it's always opposite the 90-degree angle. Now here's what I want you to know. I know it's a 90-degree angle because whenever something is a certain height, you always have to be perpendicular to the ground. When you guys go get your height measured at the hospital or whatever, or a physical, right? You don't stand when they're measuring your height. You don't stand like this, do you? They tell you stand up nice and tall, nice and straight, perpendicular. You're not leaning like this, right? You need to be nice and tall, perpendicular, 90-degree angle from you to the ground. So that's why I know that the 90-degree angle is right there. Okay? And you guys realize that the opposite side is the height of the tree? It's not asking you for the height of the tree. It's asking you for the line that's direct from the dog to the squirrel. So which one is that one?
Is this choice?
Okay, so cosine is adjacent over hypotenuse. That's the correct one to use. You have the adjacent side and you need the hypotenuse, which is the line directly from the dog to the squirrel. You're not going to use sine because sine is using the height of the tree over the hypotenuse, and you don't know either of those two. You're not going to use tangent because tangent is the opposite over the adjacent. You could use tangent, get the height of the tree, and then you could do Pythagorean theorem to get the hypotenuse if you wanted to. But you understand that you can go right into solving it and just use the cosine. So cosine of 40 degrees is equal to the adjacent, which is 8 meters, over the hypotenuse, which I don't know the hypotenuse. And that's what you're being asked. So you can label it X if you want. Okay? So Dominic, you see on this one we have the X on the bottom again? So what would be the right first step to make? Yeah, you need to multiply that. You don't want the letter to stay on the denominator of the fraction, okay? So multiply by X. Now that doesn't mean you're done though, okay? By multiplying by the X, now you rewrite it. X cosine of 40 is equal to 8. From there, what do you do next? Divide by 1. If you divide by 8, look at what happens. Notice how you move everything to the same side, and remember the whole goal when you're solving an equation is to get the letter by itself completely. Yes, divide by the cosine of 40 instead. And you guys agree that X is being multiplied by the cosine of 40, so the opposite of multiplication is division. Yeah. So divide by cosine of 40 to both sides. Now go ahead and type in 8 divided by cosine of 40 in your calculator. I typed it into the calculator, okay? Let's see if we all get the same answer. Yeah? 10.44? Okay. So that's telling you that your value of x is equal to 10.44, and the units that are being used are meters, so 10.44 meters. Do they ask us to change our answer to any type of feet, miles, or anything like that, or round off to anything?
It says the direct line distance.
So the direct line distance is from the dog to the squirrel, so that was the hypotenuse we just figured out. Yeah. One question, Paul?
Yeah, just to make sure you divide by x with the denominator.
I divided by x.
No, in the beginning.
Oh, in the beginning I had 8 over x because the cosine is adjacent divided by hypotenuse. The hypotenuse is x. We don't know what x is. So when we set up the equation, to undo the division of x, we had to multiply by x. And it's because you can't, when you solve an equation, you always want the equation to be on the variable to be on the numerator as a positive one. So we had to get it out of the denominator first of all.
So if it was on
If it was on the top and it was reversed, and let's say it was x over it, all you would have to do would be to multiply by 8 to both sides and then simplify and you would get the answer. Because remember, whenever we're solving equations, what variable are you trying to figure out? Okay? And this answer right here, we don't have to convert it into anything. The units were already given in meters, so we leave our answer in meters. Unless they were, remember the problem that we had to change the feet into miles? And you had to read that problem carefully now. That's why when I had you guys read those examples, go back to them if you did, okay? Everybody okay with that one, number 5? Yep. Okay, let's move on to number 6. All right, number 6. Now, one thing that I want to point out to you guys is everything starts with you reading the question carefully. After you read the question carefully, you have to try to figure out a drawing that goes with the question, okay? So when you're thinking about what to do first, after you read it, try to get some type of orientation of are they starting at the bottom of the ground? Does everybody realize on this problem, they're talking about a ship on water? So do you see that with the limited space that you have here, that the ship should not be drawn on the bottom because you're talking about everything below the ship? So does it make sense why I'm going to draw a ship up here on the top, and I need a space underneath the water? All right. The next part is its radar detects a submarine. Now you guys understand that a radar will pretty much go in a circular radius. Only that section that is the radar works for is in some type of a circular radius. Okay? So it says it detects a submarine at a distance of 238 feet. But then it says at an angle of depression of 23 degrees. So before you write the 238 on anything, you got to remember the boat's up here. The angle of depression then goes like this, doesn't it? So that means that the boat is detecting something 238 feet away from it at an angle of depression of 23 degrees. And from there, you've got to be able to draw that right triangle. If you don't draw the right triangle in your picture, something needs to finish that last part of the drawing. So does everybody see that the submarine, let's say the submarine is the color, and the submarine's over here. And the radar detected it 238 feet away. Okay? All right, now, did you guys solve this one?
No. At first, I got confused on the saying the distance. I didn't know if it was saying like the straight line distance of it.
Okay. And this is where that made the difference. If it didn't say that angle of depression, then you would think, okay, is it right below the ship then? 238 feet down? Because if it's 238 feet below the ship, look at what the question is asking. How deep underwater is the submarine? If the submarine is directly underneath the boat, you've answered the question in the problem already. It's 238 feet. But it didn't say that. It said 238 feet with an angle of depression. Looking at it. All right, now from there, you've got to label all your sides that you're giving. So does everybody see the angle that is given? This is your opposite, and the opposite is the depth of the submarine. That's what you're trying to solve for, is the depth of the submarine. So that's going to be our X. Do you guys see that the adjacent is over here on the top of the water from the boat to the line perpendicular to the sun? Over here is your hypotenuse. Alright, so which one will help us? So which one of those three is going to be the one we need? Sine? Okay. Sine has opposite and hypotenuse. Opposite and hypotenuse are the two sides that we have. We already have the angle. So we're going to use sine of 23. Remember, the angle always goes with that, where the theta would be. 23 is equal to opposite over hypotenuse, which is 238. Now, to solve this one, Cole, what would you do to solve that one? Alright, good. Times by 238 to both sides. You notice that that will give you x completely alone. X is equal to 238 times the sine of 23. You guys get from that? $92.99. Does that, everybody agree that those numbers are correct? 92.99? Yes? I'm waiting on 3 of you to agree or not. Yeah? No? If you're not getting that number, then something's wrong. Either I messed up. Got it? Yeah? Okay, so what did you get it? Yes? Yeah? Okay, all right. Everybody agree we got 92.99? All right. How deep underwater is the submarine? Would it be safe to say 93 feet? Yeah. 93 feet. Now keep in mind something. We're gonna go measure the tree outside, and we're gonna measure the building. Okay. When we measure the tree in the building, keep in mind, depending on what meter stick I give you, this meter stick has 36 inches in it. Okay. This meter stick has 39 inches. they really are not the same height. So just be aware of that. Usually, I believe a meter stick, if I'm mistaken, is 36 inches. 1 meter. There's 3 feet in 1 meter. Okay? 3 feet. Right. Now, if you've ever been in a pool, okay, let's say the pool is 6 feet deep, so it's this tall, right? I'm almost. I'm not 6 foot tall. Close to it. All right. And who has never been in a pool? All right. Everybody's been in a pool. Okay. Have you been in a pool that's deeper than 6 feet? Anybody? Yeah. Have you ever gone lower than 6 feet? What did you feel? Feel your ears pop? Your nose hurt? Pressure? Did you feel pressure? Yeah. Now, if you go deeper and deeper, you start to feel the pressure start to push on your extremities and everything. You'll feel it quicker on your face. You're not going to feel it so much on your legs, but you will feel it on your chest. Okay? These are the parts that are, I guess, the most sensitive areas in here. So that's what you start to feel. Imagine what 93 feet below the ocean would feel like. That's a lot of pressure, yeah? Okay. Now, keep in mind that, I have to be careful. The sun is at an angle of elevation 58 degrees. So does it make sense? We did answer that last question, by the way, didn't we? Yeah. No. The sun is at an angle of elevation. Do you guys agree that something like that? 58 degrees. There's the sun, yes? Now, do you guys realize that the sun is not the brightest star out in space? That there are stars huge, way bigger than the sun. Yeah, we can't see it. But we can see the sun.
Just shows you how big space is.
Right, space is huge. Now, it says a tree casts a shadow 20 meters long on the ground. How tall is the tree? Now watch this. Let's say the tree is right here. Christmas tree, because Christmas is coming up. All right, trick question. Is the shadow on the left of the tree or on the right of the tree?
The left.
Everybody say left? You are correct. You guys agree that the shadow of the tree should be right there? All right. So let's say the shadow goes all the way and extends to right here. That shadow is 20 meters long, right? And it says, how tall is the tree? So what we're going to do is, we're going to figure out, well, so on. Does it make sense that the shadow of the tree is not over here? Your common sense, your reasoning, everything that you've ever learned is telling you the sun's over here. The shadow should be on the opposite side. Because this part should be dark, shouldn't it? Just remember that, because I'm going to get back to something about space, okay? Which one of these three are we going to use to find the height of the tree? Because this is what you guys are going to do today. Tangent. Opposite over adjacent. So tangent of 58 is equal to the opposite. Now, everybody agree that the height of the tree is the opposite side? Opposite over adjacent, which is 20 meters. solve it for x. Tell me what you do.
X down to the right.
All right, notice that the x is on the top of the fraction. If the x would have been on the bottom, multiply by x first, and then divide by tangent of 58. So go ahead and type 20 tangent of 58 on your calculator. You don't have to hit times 20 times. You can just type in 20 tangent of 58. Should give you the same number I'm getting, yeah? 32.0666. All right. So that means that's 32.0067, and that's in meters. 32 meters. Now I want you to think about something. This is considered, not this one. This one. 36 inches is considered 1 meter. So imagine 32 of these stacked up together vertically. Now it's going to start to get like the height of the tree. That's pretty tall. Yeah. Okay. All right, so on the problem that we're doing right now, our angle was 41. We got 364.5 inches from the spot where we were standing to the base of the tree. We're going to find the height of the tree . Okay, so 364.5 times the tangent of 41 . Did you guys get that number right there? 316. That's 316.9 inches approximately. There's only one thing missing. Can anybody remember what's missing? It's not on the calculator. What's missing? Because that's not the height of the tree years. Huh? Okay, nearest foot, but there's still something else that's missing. What do you think? Your eye height. Did I do the angle measurement? So I need to get your eye height. Just stand here real quick. 12 inches, everybody agree? 12 inches are in 1 foot. All right, so remember we had to get the eye height still, so that was 60 inches. Added that to the height that we got, because that's not the total height of the tree yet. 376.9, everybody divide that by 12. Okay, so 31.4, that would be feet now. 31.4 feet. Now, one thing is different. I did this with a student the other day, and we got about 22 feet. In my last class, I had some people who had 26 feet, 29 feet, 49 feet, and 50 feet. It all depends on your eye height and the angle. Now, do you guys agree that, let's see, to this ceiling, this is 6 feet, yes? Could I fit another 6 feet before I get to the ceiling? Yeah, easy. That's 12 feet total, right? So let's just roughly say this building, the ceiling is 15 feet. So if the tree is 30 feet tall, that means the tree is 2 stories. If this was a building, 2-story tall. That sounds about right, isn't it? 31 feet, 31.4 feet. Now you gotta remember, we can't climb up that tree. I can't climb up that tree. I could climb up maybe the first 8 feet of it, but then after that, I don't think I could handle it. That's probably a good estimate. It's about 31 feet tall. This ceiling, 15 feet tall, sounds about right. Now I can measure up to a certain point, but then I need help. I'd have to stand on a ladder and have somebody help me use the beach. Yeah. Okay. Now, we didn't do the activity with the building. Everybody else got to do it. Okay. But the building, we would do the same thing. We get our angle of elevation. We have to make sure we get the eye height. Okay. All right. Any questions on that part? How to get the height of the tree? Okay. Notice I didn't need a big old ladder to get to the top. I can kind of estimate. Now, if our angles are off by a little bit, and even just the angle off by a little bit changes the answer. Okay? And, alright, this is the last problem I'm going to go over, okay? Two observers are on the ground and they're looking at the top of the same tree. So let's pretend that, alright, there's a tree, yep. Alright, I'm going to put observer number 1 over here. And then I'm going to put another observer over here. 6 figures, okay? Try to make this work. Alright, they're both looking at the tree. One of them is 83 feet away. And he looks up at an angle of elevation to be 58 degrees. Now that's assuming if his eyes are down here on the bottom of the ground. Okay. Over here, the second observer is 60 or 46 feet away from the tree. It says, how tall is the tree to the nearest foot? Do you see that observer number 1 has the information that will help us solve it? You guys understand observer number 2 doesn't have enough information being given? Okay. Alright, so can you set up an equation for observer number 1 to get the height of the tree? Which one do you think it is? Sine, cosine, or tan? Cosine? Cosine, toa. Cosine says the adjacent and the hypotenuse. It says, how tall is the tree? So do you guys agree that the opposite and the adjacent will help us? So that would be tangent. So tangent of 58 is equal to the height of the tree over 83. Right? Multiply 83 times tangent of 58. 132.82. Now the question says to round your answer to the nearest foot. So what would be the answer to the nearest foot? $133 feet. Now do you notice that the next question says at what angle of elevation must the second observer look up to see the top of the tree? Notice we already know what the tree height is. So I know the opposite and I know the adjacent. I just don't know the angle measurement, right? So I'm still going to use tangent. Tangent of theta is equal to 133 over 46. You understand? I'm looking at trying to figure out what the angle of elevation the other person is standing. Okay. All right. To solve this one, you guys remember what to do? Inverse. So tangent inverse of 133 over 46. So tangent inverse of 133 over 46 Now, everybody remember how to get tangent inverse on the screen? Second button, tangent button, yeah? And then type in 133 divided by 46. Okay. You guys getting the same number as I? Alright. 70.92. Does this make sense? That the person is closer to the tree, so his angle of elevation is going to be even higher than the person further away from the tree? Yeah? Now, any questions on that one right there? No? Alright, I didn't get to do the ones after that, but I need you guys to finish the rest of those, okay? And please, don't forget that we're going to try to finish this unit next week.